What's going on, you guys? Mr. Allen here with some end behavior of different polynomial functions given their graphs. So it looks like for this first one here, we've got ourselves a cubic function, a positive cubic function. So let's go ahead and write up our end behavior with proper notation. I like to start with the negative infinity for x first. So as x approaches negative infinity, what is our graph doing? F of x is approaching, as we go this way, it's going down, negative infinity. Beautiful. And as x approaches positive infinity, so as we go to the right, what's this graph doing? It's going up. So we get f of x is approaching positive infinity. Beautiful. First one, donezo. All right, next one, we'll switch colors here. I'm going to switch colors every time, if I remember. Okay. Oh boy, what kind of function is this? It looks like, let's see here, 1, 2, 3, 4. We got 4 local extrema, right? So that's likely at least a quintic function, degree of 5, for those of you wondering, all right? So for this one here, again, I'm going to start it with as x approaches negative infinity. Well, what's my function doing? As I go to the left, it's going up. So f of x, or whatever this function name is approaching positive infinity. Yay! Be careful if you're filling in the blank on these. Some people start with positive infinity and then go to negative infinity after that. So, but if you're writing it, you can choose, right? But if it's already set up for you, make sure you pay attention to what x is approaching for this one here. We can even use this kind of notation. We're talking about asymptotes of rational functions. That's later on. But you'll see this notation here in different scenarios. So I got as x approaches positive infinity, as I go to the right, it's going down. All right, so f of x approaches negative infinity. It's important to put like regular words to these notations here. This top line, as x goes to negative infinity, that's just saying as we look at the left side of our graph, as we go to the far left side of our graph, what's my graph doing? It's going up. This means it's going up. And this part down here, as x goes to positive infinity, that means as I go to the right, what's my graph doing? F of x is going to negative infinity. That's saying that my graph is going down, okay? So that's your normal speaking of what in the heck it is. You need to also be able to write it formally as a mathematician. Yes? All right. Next one here. I'm gonna go green. That's gonna look kind of similar. I'll go blue. All right. So it looks like here we have ourselves a quartic function. We got 1, 2, 3 local extrema, right? One absolute max there, but that's gonna be a quartic function at least, right? It could be more than that. Oftentimes we'll ask you those questions, be like, what's it at least? Okay. So as x approaches negative infinity, as I go to the left here, what's it doing? It's going down, yellow and timber. All right, so f of x, f of x approaches negative infinity. And as I go to the right, so as x approaches infinity, as x approaches positive infinity, f of x approaches, still going down, negative infinity. So let's take a moment here, take a moment to reflect, mathematically reflect, not reflect like a graph. Anywho, that's hilarious. My two odd degree functions, right? We said this is likely a cubic and this is a quintic, right? Degree of 3, degree of 5. Notice how their end behaviors are different here, right? Whereas with the even degree, our quartic, we're assuming here, at least a quartic, they're both the same. They're both negative. That's going to happen every single time, okay? So we've got ourselves an odd degree. It looks like a linear function here, yes? My end behaviors should be different. One should be positive, one should be negative. So as x approaches negative infinity, as I go to the left, my graph is going up. So f of x is approaching positive infinity. And as x approaches positive infinity, as I go to the right, my graph's going down. F of x approaches negative infinity. Beautiful. Lovely. Fantastic. All right, I'm running out of colors here, man. I think I'm going to have to swing back to pink. Actually, I'll do green. It does look kind of similar to this one, though. All right. Looks like a quadratic, degree of 2, even, so they should be the same. Notice how they're both pointing up, so my end behaviors are both going to be positive. All right, so as x, I'm saying as, very, drawn out there. F of x approaches positive infinity. It's going up. And as x goes to positive infinity, f of x goes to positive infinity as well. Lovely. Fantastic. Woo, it's a lot of writing here, man. All right, last one, I'm going to go pink again. All right, so here, another even degree. It looks like another quartic function, but this time positive, so it's going to look just like this one, but they'll both be positive infinity. So we got as x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x approaches positive infinity. Again, as I go to the left, my graph's going up. That means it's going up. As I go to the right, it's going up. Boop. Nice. All right. Takes a little practice. I know this type of notation here is a little intimidating. A lot of formal notation is kind of intimidating, which is why I like to put common folk words to it. As I go left, I'm going up. As I go right, I'm going up. That's how that last one reads. Hopefully that helps you guys. And there's a ton of stuff with polynomials, right? So hard to keep everything straight. Practice makes perfect. Deuces.